Hi Flashes, today we are going to be talking about quotient of powers property. So again, just like yesterday with product of powers, there is a rule when you are dividing with powers. So the rule is when you are dividing bases, so when you are dividing by the same base, so here our bases are x's, all that you have to do is subtract the exponents. So yesterday when you are multiplying with exponents, you add the exponents. Today with quotients, you are subtracting the exponents. So again, if you have same base and you're dividing, you keep the same base and then you subtract your a minus b. So let's do a couple of examples. So notice here how a, we have the same base of 5 and we are dividing. So the rule says that you are going to keep your same base and then you are just going to subtract your exponents. So here we have 8 minus 3, which 8 minus 3 gives us 5 to the 5th power. Okay. Please remember, if you have an exponent that is 5 or less, we do want you guys to simplify that. So you guys can use your calculator. So when you guys take 5 to the 5th power, let me find my exponent, there it is. 5 to the 5th power is 3,125. Okay, so let's try the next one. 10 to the 11th divided by 10 to the 7th. So again, if you have same bases, the rule says when you divide with exponents, you keep your same base. So we are going to keep our base of 10 and then subtract your exponents since we are dividing. So 11 minus 7 gives us 10 to the 4th. Again, since we have our exponent that's less than 5, we do want you guys to simplify it. So if we were to take 10 to the 4th power here, it gives us 10,000. Okay, so let's try the next one. So we have 4 to the 6th divided by 4. Remember, if there's no exponent with a number, you can add the imaginary 1 to it because 4 is the same thing as 4 to the 1st power. So that then when you guys simplify this, you keep your base of 4 and then you subtract your exponent. So we do have a 1 here attached to the 4. So we do need to take 6 minus 1. So 6 minus 1 gives us 5. So this would be simplified to 4 to the 5th power. Okay. And again, we do need to simplify. So if we were to take 4 to the 5th, we get 1024. Alright, so let me try one more with you guys, and I'll have you guys try a couple. So 3 to the 2nd divided by 3 to the 2nd. Again, if you're dividing with same bases here, you keep the base that you have. So we're going to keep 3. And then the rule says when you're dividing with exponents, you just subtract them. So 2 minus 2 would give us 3 to the 0 power. Now, I am going to talk about anything to the 0 power on Thursday, but if you guys were to simplify this in your calculator, anything to the 0 power is just going to equal 1. So our answer here is just 1. And then again, I'll talk more about why that is on Thursday. Okay. Alright, so I want you guys to try E and F. So go ahead and pause the video and try E and F on your own, and then press play when you're ready for the answers. Alright, so you guys should be done with E and F, so let's see if you did them correctly. So for E, your base was 7, and then you are dividing with exponents, so you should subtract them. So 8 minus 6 gives you to the power of 2. And 7 squared equals 49. Alright, and then the last one, so your bases were 9, so you should have kept your base of 9, and then you should have subtracted your 3 minus 5, and this will give us a negative exponent, which is okay, but tomorrow I am going to talk about why we can't keep negative exponents. But for right now, this is fine. Okay, if you did plug this in your calculator, so 9 to the negative 81. Okay, and again, you can keep this for now, but tomorrow you are going to learn that you have to write it like this. Okay? All right, so good job if you guys got that. So this is just the basic rule of quotient of powers. So if you have the same base, you keep the same base, and then you just subtract your exponents. Okay? Onto the back side, there is some more simplifying, but we now have some coefficients that we have to be careful of. So remember yesterday with coefficients, we talked about how if you had like 2x squared times 3x squared, remember your coefficients in this case are 2 and 3. So you have to simplify your coefficients by doing the operation first. So what you guys had to do here was take 2 times 3 to give you 6. And then you can go back to your bases. So your bases were x, so you're going to keep your base of x. And then the rule with multiplying with exponents is you just add the exponents together. So 2 plus 2 would give you 4. So we are still using the same logic with coefficients when we are dealing with dividing. So you always want to simplify the coefficients first with dividing them. And then you can move on to the bases and do what we just did. Okay? So notice here for A, notice how we have no coefficients, we just have bases, so we are just going to do what we have been like normal. So we're going to keep our same base of G, and then the rule says to subtract your exponents, so 12 minus 7, so this is going to give us G to the 5th power. Now look at B. So notice how 12 and 8 are our coefficients. So the first thing that we need to do is simplify those by dividing. If you cannot divide these into a whole number, okay, so like if I were to take 12 divided by 8, since those are my, sorry, my video paused. If you cannot divide your coefficients into a whole number, so like if I were to take 12 divided by 8, I got 1.5. You do not want to put the decimal in your answer. All that you are going to do is simplify like normal. So like if I were to tell you guys how can you simplify 12 divided by 8 into a simplified improper fraction, you guys would tell me, oh, we can divide by 2, or no, we can divide by 4, because that would be a bigger number that we can divide by. So if I simplify these by 4, 12 divided by 4 is 3, and 8 divided by 4 is 2. So my simplified expression, or my simplified fraction, would be 3 over 2. So this is the same logic that you have to do over here. So as soon as you guys see coefficients, you do want to divide them. But if they do not go into a whole number, all that you are going to do is you are going to simplify the fraction into its improper fraction. So 12/8 simplified is 3 over 2. So you are going to keep the 3 over 2 in your fraction. Okay, so again, let me recap. If you have coefficients, just like we did yesterday with the products, you first have to simplify the coefficients by doing whatever operation it says. So yesterday was multiplying, so we just took 2 times 3 to get 6. Today, when you're simplifying your coefficients, we are dividing. So as we know, if we are dividing and we do not get a whole number, you are just going to get a simplified fraction. So 12/8 reduced is 3 over 2. Okay? Then, notice your exponents. So we have n to the 5th and n to the 2nd. Okay? Notice how we have more n's up here on top and less n's down here at the bottom. Now let me just represent this to you guys visually. So we are still going to do the same thing like we did up here. We took 12 minus 7 to our g's to get g to the 5th. So same thing up here, we're going to take 5 minus 2 to get n to the 3rd. But I'm going to show you guys why we keep n to the 3rd in the numerator and not in the denominator. So let's say I write n to the 5th 5 times, but instead of writing n to the 5th, I'm going to put it as n to the 1st, because if I were to add them, they would then give me n to the 5th. So let's just do this 5 times. 1, 2, 3, 4, 5. And then let me just do the same thing down here at the bottom. So 1, 2. So into the fifth, I rewrote that 5 times for into the first. Into the second, I wrote it 2 times into the first. So notice what happens. So when we know that we are dividing, we are really just canceling stuff out if you have the same stuff in the top and the bottom, so in the numerator and in the denominator. So notice how I can cancel out 2 n's to the first because I have 2 up here and 2 down here. So notice what I'm left with. I'm noticed with 3 n to the first powers up in the numerator. So I can combine these together by adding my exponents, and I would get n to the third power. So my simplified expression would be 3n to the third over 2. And this makes sense, right? Because if I were to take n to the fifth divided by n to the second, remember you just subtract your exponents, so 5 minus 2 is 3, keep your same base of n, and that is why it goes up in the numerator, because you had more n to the first powers up top compared to the bottom. So that's why this is your answer. So you guys don't have to write this. I was just giving you guys a visual representation of when you guys take n to the fifth divided by n to the second, why your n to the third stays up in the numerator and not in the denominator. Okay. All right, so let's move on to C. So again, as soon as you guys see that we have coefficients, so here we have 7 and 21, you need to do whatever operation is being asked of them to do. So 7 over 21 means that we are dividing. So if I were to take 7 divided by 21, that's not going to give me a whole number. So what I'm going to have to do is I'm just going to have to simplify it. So what I can simplify these by is by 7. So 7 over 21 is really just 1/3. So if I were to simplify my coefficients, I'm going to have 1/3 over here. And then I just need to simplify my bases like normal. So I have c to the 9th and c to the 3rd. Again, the rule says you keep your same base, so I'm going to keep my base of c, and then I'm just going to subtract my exponents. So 9 minus 3 would give me 6. And remember, you just need to decide if it's going to go up top or up bottom. Notice how we have more c's up top than we do at the bottom. So again, I can give you guys a visual representation. We have 9 c's up here, and we have 3 c's down here. So if I were to cancel out my c's that match up the top and the bottom, again, I have still more c's up top. So that is why your c to the 6 is going to be in the numerator and not the denominator. And again, we said that c to the 9th divided by c to the 3rd, you just subtract your exponents. You just subtract your exponents, so 9 minus 3 was 6. And then we kept it in the numerator because we had more c's in the numerator compared to the denominator. Okay, so main thing, guys, is if you just have your bases with no coefficients, you're just doing it like normal. So you're keeping your base, subtracting your exponents to simplify it. If you do have coefficients, you always have to simplify your coefficients first by doing whatever operation is happening. So we are dividing, so I just simplify them into its simplified fraction. And then when you get to the bases, you're doing just like you did up here with A. So you are subtracting the exponents, and then wherever the most n's are at, that is where it's going to place in your numerator or denominator. Okay? Okay, so now let's say we have a power of a quotient. Okay, so to apply the power of a quotient property, you're going to simplify inside the parentheses and distribute the outside exponent to every term in the numerator and the denominator into the parentheses. So what this really means, let me see what they did on the back side. So if we have like x to the a power over x to the b power, all to the power of let's do to the power of like c. Okay, so if we have x to the a over x to the b all over to the power of c, you first would have to simplify what's on the inside first, and then you would have to take it to this power by multiplying your exponents. Okay, so let's just do a couple of examples. So here we have a over 6 to the power of 2. So again, if you cannot simplify the inside of your parentheses, which in this case we cannot, then you can move to the outside with that 2. So what you're going to do is this 2 is going to go with the a, and it's going to go with the 6. So when you guys simplify this, this is going to be a to the second power over 6 to the second power. So you are just attaching the power of 2 with the a and with the 6, and then you can simplify this if you can. So notice how we cannot simplify a to the second, so a to the second is just going to stay the same, but you can simplify 6 squared because 6 squared is just 36. So your answer here is a squared over 36. Okay, so let's try the next one. So again, if you cannot simplify on the inside of your parentheses, that's when you move to the outside. And here we have an exponent, so we are going to attach this exponent to everything on the inside here. So your x now turns into an x squared. Your negative 9 now turns into a negative 9 squared. And then you simplify it like normal. So your x squared cannot be simplified, so it's going to stay the same. Your negative 9 squared can be simplified, because if you were to take negative 9 times negative 9, that would give you a positive 81. Okay, so let's try another one. So again, you always want to first check to make sure that you can't simplify on the inside of your parentheses, which in this case I cannot. So that's when you move to the outside. So remember, this 5 goes to every single item on the inside of your parentheses. So your 5 is going to go with the x, your 5 is going to go with the y. But please don't forget, if you have a coefficient to a power, this power still attaches to that coefficient. So this is what this simplified expression is going to look like. So x to the power of 5 is just x to the 5th power. And then when you take 2y to the 5th power, the 5 goes to the 2 and the 5 goes to the y. So this is going to be 2 to the 5th power times y to the 5th power. So again, that 5 goes to every single item on the inside of that parentheses, and then you are just going to simplify like normal. So we can't do anything with that x to the 5th, so that's going to stay the same. Remember, if you have an exponent of 5 attached with the base of a numerical number, you can simplify that like normal in your calculator. So 2 to the 5th power is 32. And then you cannot simplify that y to the 5th, so that would be your answer. Alright, so I want you guys to go ahead and try the last one. And go ahead and pause the video and then press play when you are ready for the answer. Alright, so you guys should be done with this one, so let's see how you did. So first thing, you guys should have looked to see if you could simplify anything on the inside, which in this case we could not. So what you had to do then was move to the outside, and you're taking this exponent of 3 and you are attaching it to everything on the inside here. So when you simplified it, it should have been negative 5 to the 3rd power over, this would be 3 to the 3rd power, and then x to the 3rd power. Now I notice here that I have some exponents that are less than 5 that I can simplify. So what you guys would do here is take negative 5 to the third power, and again you guys can use your calculator. So if you were to take negative 5 to the third power, you get negative 125. Down here, if you were to take 3 to the third power, that's 27. And then you're going to keep x to the third. And that is your simplified expression. Now I do want to do one more with you guys because none of these examples you had to simplify on the inside first. So I just want to show you guys what that would look like because it does show up on your guys' test. So I'm just going to take one of the ones that we did up here. So let's say I take B. And I'm not going to simplify it yet like we did over here. So I'm going to take 12 into the fifth over 8 into the second, and I'm going to take all of that to the power of 2. So 12 into the fifth over 8 into the second, all of that to the power of 2. Okay, so again, you must simplify everything on the inside first before you move to the outside. So I notice here that I have some coefficients that I can simplify. I have some ends that I can simplify. So I want to do that first. So again, if you have coefficients when you're dividing, the first thing that you want to do is simplify that fraction. So if you had 12 over 8, just like we talked about up top, 4 goes into both 12 and 8. So if you were to simplify that, 12 divided by 4 was 3. 8 divided by 4 was 2. So your guys' new coefficients instead of 12 over 8 is 3 over 2. Then I still have some ends that I can simplify. So I have n to the fifth over n to the second. So again, what you guys are going to do is keep your base of n and then subtract your exponents. So if you were to take 5 minus 2, that gives you 3. And notice how there were more n's up top compared to bottom. So your n to the third is also going to go up top. And then all of this is still to the power of 2. Okay? So this is what we got up here, right? So we first had to simplify, and we got 3n cubed over 2. But now we are going to take it to the power of 2. So again, this 2 goes to everything on the inside of this parentheses. So the 2 is going to go with the 3. The 2 is going to go with the n to the third. And the 2 is going to go with the 2 at the bottom. So let's see what happens. So if the 2 goes with the 3, this would be 3 to the second power. And then if the 2 goes with the n cubed, remember if you have a power to a power, you just multiply the numbers. You just multiply the exponents. So 3 times 2 is 6. So this would be n to the sixth power over. And then your 2 goes with the 2 here, so this would be 2 to the second power. Okay, and then again, we still need to simplify. So simplify your exponents that have exponents less than 5. So 3 squared is 9. You can't do anything with the n to the 6, so you're just going to rewrite that. And then 2 squared gives you 4. So that would be your simplified expression, okay? So again, if you can't simplify on the anything, that's when you move to the outside and go ahead and attach the exponent with everything on the inside and then just simplify like normal. But if you have a problem like this that you can simplify on the inside first, you must do that first before you start taking that exponent to everything on the inside, okay? So this is it for today's lesson. Please, please, please ask your guys' teacher for help if you guys need help. We are here to help you. This is a more difficult unit because there's a bunch of rules and a bunch of steps that you guys have to remember. So please, please, please ask for help if you guys need it, okay? So hope you guys have a great rest of your day.